We're continuing the sampling distribution concept, and this time we're going to use a different statistic called the sample proportion. A proportion is an average of zeros and ones, where every observation is classified as failed to see the event, and this will get a 0, or saw the event, and this will get designated a 1. Now, a proportion is a divider. I like to call a divider of your data into those that succeed and those that fail. Now, notice that the sample proportion can be used for both categorical and quantitative data. For numerical data, we can summarize data by taking an average, we call the mean, and that's what we did previously, and produce a sample mean. But we can also use a proportion. But if we're going to use a proportion, we're going to have to classify or define event we want to see. So a proportion has a next level of requirement, defining an event that you want to observe. And all proportion does is observe whether you saw an event or you did not see that event. Consider the 5 data points measured cholesterol levels, measured in milligrams per deciliter. In adults over the 40 years of age, we can adjust the average of those numbers or find a proportion that meet our criteria. Say adults with cholesterol levels over 200 deciliters. So now this is going to be the criteria that we're after. And we're going to try and find a proportion. So the symbol used to denote the sample proportion is known as p hat. Well, in fact, it's pronounced p hat, and this is the symbol. I have these two backwards. So this is known as p hat, and this is a symbol for that. And now notice we've defined a criteria. This data is numerical. I could take an average of this. As a matter of fact, let me just do that. This would be another statistic. So all I would do was add these up. So I got 1, 2, 3, 4, 5. And then calculate the average. And in this case, it's 195.4 milligrams per deciliter. And that's how, again, the average works, which you know. But to do a proportion, we need criteria. And in this case, this is my criteria. So I check my criteria. Does that meet it? No, it has to be above 200. Meet the criteria? No. Meet the criteria? No. Meet the criteria? No. Meet the criteria? Yes. So p hat just does the following. Sums these up and divide by how many observations, which would get 20%. Okay, so you notice this is also a mean, but it's a mean of zeros and ones, and that's what we say. A proportion is an average of zeros and ones. So proportion is a mean, but a very special mean. A mean that divides the data into 2 sets. One set says, I did not see what I wanted to see. The other set says, I saw what I wanted to see. And so you need that level of criteria. So just like a sample mean, the sample proportion we just calculated belongs to a distribution of all possible sample proportions from the population where the 5 measurements came from, called the sample distribution of the proportion. So because now our statistic is a proportion, so then this belongs to the sample distribution of the proportion for a sample size of 5. So imagine all possible sample sizes of 5. For categorical data, we do the same. Focus on a particular characteristic we're interested in and count how many in our sample meet those criteria. Consider a sample of people that are asked if they voted in the last election. We're interested in those that voted. So this is now what? The criteria. Those that voted is the criteria we want to observe. Now, this isn't failure because we did not see what we wanted to see. Success, success, failure, 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 success, failure. Notice this is categorical data, unlike the other one. But no matter what, whether it's categorical or numerical, you need a criteria, some criteria to split the data, because a proportion splits the data into two parts, successes and failures. What's p hat in this case? Well, I could do exactly what I did here, add the zeros and divide by the total, but that's not the way we normally do it in real life, because we just ignore, knowing that we were going to add and the zeros don't add up to anything. We just count how many successes there were. 1, 2, 3. And then out of 1, 2, 3, 4, 5, 6, 7, 8. So there's my p hat. So again, we could do this, but we recognize that the zeros don't add anything, so we just count successes. In this case, it would have been 1 out of 5. Next, we're going to go to just one more time, website. So what I'm going now is random.org. So quick search for that right here. And it takes me to this website, random.org. And what I want to do is find simulator that tosses coin. Oh, it's right up here, games and lotteries, coin flipper. I'm going to flip a coin 10 times. I need to select a coin type. I'm going to choose Todd Redden's Decision Maker coin. And I'm going to flip it. Notice there's two sides of this coin. And what I want to do here is says, okay, toss a coin 10 times. When you get a tail, mark 1, if heads, 0. So what's head? Well, let's say that heads is do it and tails is the hell with it. If that's the case, looks like success. It's going to be the hell with it. Keeping that in mind, I look at my first coin up there, and that's a failure. Then success, success, failure, success, failure, success, 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 success. Now, I chose the hell with it as success just because sometimes people say, well, success is something good. No, success is nothing good. Success could be something really bad, but that's the thing we want to observe. Failure doesn't mean that it is bad. Failure is just means that I do not want to observe that. In medicine, it could be how many people died in some kind of situation, and that would be success. But of course, people dying is not a successful situation in real life. But success is all we want to observe. If I flip again, well, what do I get this time? I got success, success, failure, 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 success, success, and failure, failure, failure. Okay. So what is your first sum? So my first sum, I got 1, 2, 3, 4, 5, 6, 7. So the sum is 7. What is your second sum? 1, 2, 3, 4, 4. Okay. What is your first sample proportion? Well, I tossed the coin 10 times, 7 out of 10. What's your second sample proportion? It should be 4 out of 10. And both of these are p hats. What is the probability that a coin lands on tails? Well, I'm assuming this is a fair coin, so 50%. So this value turns out to be what? Well, the mean, this value, which we're now going to call p. And this is a parameter. The mean of the distribution of all possible coin tosses, which is infinite in size. This will be the mean. In other words, if I now look at my symbolism, this will represent the mean of sampling distribution of proportions for a fixed sample size. And that's always true of sampling distributions. They have to be for a fixed sample size. So what I'm saying here is that symbolically, E of P is P. So this is also the symbol for the parameter P. This is just a general symbol for the mean of that. So it just turns out that, notice this number, what is this number? This is success or chance of success for a single observation. So what's the probability that a coin lands on head? 50%. It turns out, again, this is the chance for success for a single observation, but it turns out this happens to be the mean of the sampling distribution of proportions for a fixed sample size. So often this would be called population proportion. Again, notice parameter is a general term. Population proportion is more precise for this particular situation. And this happens to be the mean. What about the standard deviation? Oh, the sampling distribution of proportions. Well, it's this. There you go. So you take P times 1 minus P divided by N, take the square root of that, and you have the standard deviation of proportion. Remember, E of P equals this number, P, only if the sampling process is unbiased. So we can only have these measurements equal this as long as our sampling process is unbiased. The purpose of P hat is to estimate P, the population proportion. The summary P hat is a statistic, while P is again, parameter. So make that distinction again. The purpose of P hat is to estimate the population proportion P. This is statistics, while this is a parameter. It happens to be also the center, this parameter P is the center of the sampling distribution of proportions. Sorry, I just realized I was off screen, and there's what I wrote down.